next part of your that is direct shear test. Diagram for direct shear test I am just drawing. Next test is your direct shear test. So, direct shear test is a equipment, this size is either 5 by 5 centimeter by 5 centimeter or 6.4 centimeter dia. It may be a circular shape or it may be a square section. If you look at this direct shear test cross sectional view, so this is a shear box. With this shear box, bottom is, it is a porous stone. This is a fixed, this part is fixed, then upper part it can be moved by means of application of lateral load. So, in this case what happened, the soil filled it off, then half of the part will be also filled by the soil. The box is connected, means this is a this box can be separated into two parts. With this, here lateral load or horizontal load applied by means of applying a proving ring here, and either you apply a proving ring here or you can apply direct load here by constant rate, measure, or maybe you can apply by strain here, or you can measure load by means of proving ring in the opposite end. Then for each vertical load, the concept is direct shear test, the concept is, suppose this is a soil sample, it acted upon by a vertical load. So, with this acted upon this vertical load, how this shear formation is there? That means this is your formation of your failure surface. The failure surface in direct shear test, it will be acted upon by vertical load, suppose say 1 kilonewton or maybe 2 kg, maybe 3 kg. So, this by area it is your vertical stress, means that is your normal stress you are applying, and this is your shear stress from lateral load. Once the moment you apply the lateral load, soil will be shear, that means soil will be shear here, because this part is moving and this is constant. With this part as it moves, soil itself will shear. Once it will move, the resistance offered by soil by means of this shear, it will be recorded. So, this proving ring will give this how much your lateral load is coming. That means you apply here, you apply your load. So, displacement you are applying, then horizontal load you are applying the pH. So, you record pH versus delta. pH means lateral load versus how much is your displacement. This displacement can be measured by means of, these are the dial gauges. So, you measure pH versus delta, from where this maximum pH maximum or lateral load you can get it, for particularly normal load you will get it maximum lateral load, that you can get it, it will go increase. Once there is a failure, what will happen, it will decrease. How do you know that it fails, soil fails by means of a shear? The moment lateral load has been applied one end, so the soil try to resist. So, it will resist means this load here proving ring, this load will increase. So, from here it will increase. The moment soil fails by means of shear, what will happen, all of a sudden it will start decreasing, That means suppose from 0, initially it is 0, it will increase to 0, 5, 10, 15 division, then once the failure occur, this will start decreasing. That means at that point you stop applying your lateral load. Then what are the conditions, how do you get it? So, for each normal load or normal stress, normal load, how do you get it? PV. From PV, vertical load, PV means vertical load and area, distorted area, load by area, that is your normal load you are getting. For each set you are getting one normal load and one shear stress, means shear stress you will get its shear load, you know it, with that area you will get your shear stress. That means suppose 1 kilonewton normal load, you will find it out 1 lateral load. From there you plot set of, means there are two unknowns, one is C, other is your phi. At least 2 tests required for this to, means for this graph to be plotted. So, for a particular normal load you will get one shear load or maybe lateral load, that then you find it out normal stress and shear stress, then you plot the graph. The intercept with your shear stress axis, this is your called C, unit cohesion, and the angle it makes with your normal stress angle, normal stress axis, this is your phi. From there you will get C and phi. So, next question is, can this is a direct shear test, can it be possible to conduct consolidated on drain test or simulate consolidated on drain test by means of direct shear test apparatus or consolidated drain test. So, suppose for example, wet and saturated cohesive soil. In case of wet and saturated cohesive soil, what will happen? In wet and saturated cohesive soil, consolidated undrained, that means you, this is the soil sample, before applying this shear, apply your normal load. So, what will happen? It will be consolidated. Then once consolidation is over, then shearing rapid by means of this lateral load, constant rate of displacement generally applied. So, constant rate of, there is a motor here, so it will give constant rate of displacement, that means, so say 2 mm per second or 3 mm per second, that means this revolution will be 2 millimeter per second, this motor will go 2 millimeter per second. That means, if you apply a very rapid displacement rate, what will happen? During undrained condition, there is undrained condition, rapid pore water pressure will develop. So, this will simulate consolidated undrained test. In case of, if I say the soil, can I simulate consolidated drain test by means of direct shear test? Question is yes, I can do consolidated drain test. So, after doing the consolidation test, because these are the porous stone, after the moment you apply normal load, what happen? The consolidation process starts. After doing consolidated drain, when consolidation for this consolidated drain test, after doing this means after this consolidation is over, what will happen? The rate of displacement you apply very slow rate. Slow rate means suppose say 1 mm per second. That means 1 second the displacement will be only 1 mm. It is so slow, what will happen? The development of pore water pressure will be very less, or it is a case of no pore pressure development. So, that will simulate consolidated drain test. That means the drainage will be there. So, no pore water pressure will develop. Consolidated undrained means consolidation applied, consolidation process will start by applying normal load. Then after consolidation process is over, you apply lateral load by means of a high rate of displacement per second, say 2 mm per second, 3 mm per second or 4 mm per second or 5 mm per second. That means the revolution or the displacement achieved by the motor for per second, suppose slow rate, it will be only 1 mm. That means for high rate it will say 5 mm. With this rate of displacement high means all of a sudden it will not get to be drained after the consolidation is over. All of a sudden the pore water pressure will develop. So, you can simulate unconsolidated undrained test by means of direct shear test, consolidated undrained test by means of direct shear test and consolidated drain test by means of direct shear test. 3 conditions can be simulated, 3 triaxial test conditions. One is your UU, other is your CU, other is your CD. These 3 tests can be simulated by your direct shear test. Direct shear test apparatus. What is the disadvantage of direct set test? Rather than, because there are 3 tests required to find it out C phi. One is your quick test that we explained last class, then next is your direct set test, then third part is your triaxial test. If I compare with direct set test with a triaxial test, what is the lacuna in, what is the drawback in direct set test? In direct set test, what will happen? The confinement is fixed, means there is no lateral pressure, there is no lateral pressure, in a way there is no lateral pressure. So, only vertical pressure is there. So, this is the major drawback in direct shear test. Now, come back to, we will discuss direct shear test as well as shear as well as your triaxial test in the next following few classes. Now, next is your triaxial test. I will show animation later about the equipment, how the triaxial test has been performed in the laboratory by means of PowerPoint presentation, maybe sometimes later. So, in triaxial shear test or triaxial test, what does it mean? Why it is called triaxial test? If this is a soil sample, why it is called triaxial test? That means the stress applied all round, you can apply stresses x, y, z, or if it is a cylindrical coordinate, if it is a circular shape or if it is a cylindrical shape, you can apply stresses all around, vertical as well as confining all around. That means, it will truly simulate the moment you take soil sample at any depth below the ground surface. That means, what will happen? This soil sample has vertical as well as lateral stress. To simulate the soil sample below the ground surface, this vertical, lateral or all around x, y, z, all around direction stresses to apply to simulate exactly this field conditions, this triaxial test has to be performed. So, what you are supposed to get in triaxial test? Before I go to explain this particularly triaxial test equipment and what are the, how this test has to be performed, what parameter you are interested to find it out? One is C prime, other is your phi prime, cohesion and angle of internal friction. The process is same, you can observe from there stress versus strain. How do you get your stress? By applying your vertically load, you will get the stress applied, increase in stress applied. So, laterally confinement already it is there, lateral pressure is there. So, how much it is displaced, the strain you can get it. Stress versus strain, if you plot it, you will find it out failure stress, peak or failure point. From there, with application of particular load or maybe stress, with increase in stress, the soil sample with a particular confining pressure, suppose this is a confining pressure say 1 kg per cm square. With this 1 kg per cm square, how much stress it can apply, how much stress it can take before the failure. So, you just apply load and increase it or apply the stress, increase it. So, that stress versus strain you will get it for particular confining pressure, you will get your peak or failure point. Now, there are two parameters. So, you have to do minimum 2 tests to get your result. That means, in that case shear stress versus normal stress, if I plot it, if I draw the Mohr circle, so draw the Mohr circle and find it out the common tangent. With this point, draw a tangent where it touches the Mohr circle or the failure point. So, this will give C and this will give you phi. With this, maximum number of, at least for as the way I said for your direct shear test, in case of triaxial test, minimum number of tests required to be performed, as there are two parameters C and phi, minimum required is 2. Generally we go for 3 samples, we will get a good result. So, minimum 2 number of samples are required, so that you will get C and phi. So, now next terminology is stress path. So, instead of plotting a Mohr circle for each stress, condition, it may be more convenient to plot stress coordinates of P1, P is equal to sigma 1 plus sigma 3 by 2, Q is equal to sigma 1 minus sigma 3 by 2. So, this locus of these points P Q, I am just writing the locus of points or locus of P Q points for a test series on a soil forms a failure line. Called KF line. Now, this is your failure, but failure line, it is at the middle KF line. KF line is different than your failure plane. PQ diagram from you will get there your KF line. Now, what is this? The moment you are saying that triaxial test, how you will get it sigma 1 and sigma 3? What is your sigma 1? Sigma 1 stress coming in major axis and minor axis, or major principal stress or minor principal stress you can say. So, suppose here this will be your sigma 3, lateral or confinement pressure coming all round, this we call sigma 3. So, sigma 1 is your vertical pressure or vertical stress applied. The moment you want to draw Mohr circle, what you will do? You will take shear stress versus normal stress, from where you will take your sigma 3, take your sigma 1 from this coordinate axis 0 0. With this, draw the Mohr circle, half of the Mohr circle. Now, question to all of you, why half of the Mohr circle has been drawn, why not full? Though it says it is mirror image of this, but still that you have to say why this we plot all where else this half of the Mohr circle, not the full, means only half. If I draw a Mohr circle, it is like this full, only half of the Mohr circle has been drawn in case of geotechnical engineering. Now, we will go for next part is your relationship between KF line and Mohr's failure envelope. the tangent which touches your Mohr circle, that is your, you can say that is phi line or failure line from you are getting from your standard triaxial test for 3 sets of confining pressure, sigma means sigma 3 1, sigma 3 2, sigma 3 4 or 3 3. But here P q with this stress path, it is passing locus of this point of the P q, it will be around in the middle. So, one, 2, 3, this is your KF line. This is your phi line, this is your KF line. This is my sigma 1, sigma 3, R, this is your phi, then this will be C and this will be A and this will be alpha, and from here to here will be M. R by M plus X, and this distance is your X tan alpha, which is equal to sin phi, which is equal to A by M. C by tan phi, A by tan alpha, C is equal to A by tan alpha tan phi, which is equal to A by tan alpha sin phi by cos phi, so which is equal to A by cos phi, A by tan alpha, C is equal to A by tan alpha into phi, alpha is equal to phi, it is equal to tan, it is equal to sin phi, which is equal to A cos phi. That means if I draw a simple Mohr circle and draw the phi line and KF line, phi line comes from your PQ diagram and phi line KF line comes from your PQ diagram and phi line comes from this tangent which touches this Mohr circle. The intercept of phi line with this ordinate, that is your C, this to this distance is your C. Intercept of KF line here, it is A, and this angle is alpha. This distance from here to here, you can name it, this is O, this is A, this is B, and this is C. OB is M. Now from simple geometry, look at this triangle, simple geometry, M plus X by R is equal to tan alpha. With this simple geometry, tan alpha is equal to R by this distance, R by M plus X, R by M plus X is equal to tan alpha. Sometimes in soil mechanics this is very small, alpha is equal to, it may be as a phi. So, which is equal to sin phi. If I write it in terms of sin phi, which is nothing but A by M, these are the two similar triangles. So, A by M, that means C by tan phi is equal to A by tan alpha. So, from there C by tan phi is equal to A by cos phi. So, C and phi can be obtained from PQ diagram. So, that means the steps. So, scaling alpha, A and M, then compute alpha is equal to tan inverse A by M, then compute cos phi and C. We will do this with a solved example right now. So, there is a given triaxial data. So, this is my test 1, 2 and 3, then sigma 3, sigma 1 is given, this is 40, 80, 120, then 103.0, 166.0, then 222.0, sigma 3 and sigma 1 is given. From there you can find it out P and Q in kPa. So, this will be 71.5. P and Q, how you will get it? P and Q, as I said earlier, so P is equal to sigma 1 plus sigma 3 by 2, Q is equal to sigma 1 minus sigma 3 by 2. So, 71.5, 123.0, 171.0, Q is equal to 31.5, 43.0, 51.0. Now, this PQ diagram has been, you plot with this calculated PQ diagram. So, this is Q and this is P. From this, once you plot P versus Q, you will get, this is my KF line, you will get this KF line. Extend it KF line, it will intercept P somewhere else here, it will cut. From there, this is your value of A. So, A is equal to 18 kPa, then M is equal to 94 kPa, then alpha is equal to, this is alpha, if you remember that last part is this is your alpha. So, alpha is equal to 11 degree. Once you plot the diagram, these are the set of test data is available from the triaxial, 3 tests, sigma 3, sigma 1 is given. Now, convert the sigma 3, sigma 1 to P and Q. Then once you get P and Q, plot your P and Q diagram. Once you plot the P and Q diagram, P and Q KF line draw, this KF line has to be extended, it will intercept the P some angle alpha, then graphically you measure what is your alpha, alpha is equal to 11 degree, A and M you can find it out from this graph. Once you get A, M and alpha, from there you can find it out sin phi is equal to tan alpha. So, phi you can get it 11.21 degree, then C is equal to A by cos phi. As I said, C is equal to A by cos phi. Here you get it earlier, C is equal to A by cos phi from this relation. From there you can find it out 18.35 kPa. That means plotting Mohr circle every time it is a cumbersome. So, you can make this sigma 1 and sigma 3 in terms of P and Q, then plot the PQ diagram. From PQ diagram find it out KF line. Once you get your KF line, alpha draw the means find it out from graphically what is the angle alpha, A and M. Once you get it, so there is a relationship between KF line as well as phi. So, sin phi is equal to tan alpha. From there you can find it out phi, and C is equal to A by cos phi. From there you can get C is equal to 18.35. That means once set of triaxials results are there, I can get PQ diagram. From there I can get C and phi, or I can plot this Mohr circle, I can get directly C and phi. We will discuss more in the next class.